Alright, so this is a tutorial on how to do the 2-bit adder. So, here we have two chips, U1 and U2. Here and here. The first thing you need to know is which one's the most significant bit and which one's the most least significant bit. The least significant bit will always be connected to ground. For example, right here, it's connected to ground. So this is the least significant bit, making this the most significant bit. Now, these are called 2-bit adders. And why are they called 2-bit adders? Well, it's because you have two possible inputs, A and B, A and B. Hence the name 2-bit adders. You have a possibility of 2 bits to add. Now, an integral part to understand this problem is to understand that these lights here, 1, 2, and 3, are just physical representations of binary. These are lights, meaning they can be on or off. And such, they can be either 1s or 0s. So really, what this 2-bit adder is doing is adding 2 digits, one from here, and displaying it in terms of lights. However, you might be wondering, if it's 2 bits, then why is there 3 bits here? 3 bits worth of binary or 3 bits worth of lights? Well, it's because when you add, sometimes you may have an overflow, or you might have a carryout. So an example of carryout would be 1 plus 1. You get a 0, that's your carry-in, and then you add 1 to this side, to the left, and that's your carryout. Now we can start the problem with this background knowledge. Let's look at this least significant bit first. Here, we see that there's a carry-in of 0. Now we see A and B both have 0s going in. So the easiest way to kind of understand this is write down A and B as your possible values. Then put 2 placeholders for what possible binary it can be. Remember, on the left is the most significant bit, and on the right is the least significant bit. And since first we're dealing with the least significant bit, we have to take in what the inputs of A and B are. So for example, this is ground. So here, the values of A is 0, the values of B is 0. So what we do is we put in 0 and 0 here. Now, once we look at the most significant bit, which is over here, what I'm highlighting now, we look at A, we look at B. They have values of 1 and 1. So what do we do now? Well, this is just simple binary addition. We do 1, 0 plus 1, 0. That's 0. Then you have 1 plus 1. You carry in a 0. You carry out a 1, and that's 1. So your final binary will be 1, 0, 0. A really easy way to understand this is imagine if this binary was placed onto these diodes here. So this will have a value of 1, 0, 0. Remember that this is the least significant bit, and this is the most significant bit. So meaning this would light on, and these would stay turned off. A physical way to imagine this is when you do the actual addition, and you have that carry out of 1 over here, what I'm highlighting in purple now, this right here, this carry out in the most significant bit is carrying that out into here, into that most significant bit. Because this number 1 here is the most significant bit. So what we understand now is how to interpret a 2-bit adder. So to run things down, first you have to find out which one's the most least significant bit and which one's the most significant bit, depending on which one's connected to ground. Then create a table for yourself, such as A and B, and fill out that table corresponding with the least significant bit and the most significant bit. So we have 0, 0, A, B as the input. So we have 0 and 0 for the least significant bits. Then you move on to the most significant bit chip. You see that there is a 1 value and a 1 value being inputted, so you add 1 and 1. Then you add these values together, simple binary addition, and you get 1, 0, 0 base 2. In decimal or in normal numbers, this is just equal to 4. 1, 2, 4. 4 is on, so decimal is 4. And that's your answer.